Welcome to Context Window, your weekly look at the bleeding edge of AI coding tools. Let's see what's new.
9 seconds. That's all it took for an AI agent powered by Claude to wipe an entire company's production database.
And the crucial detail there isn't just the speed, but the context. It wasn't a malicious attack, but an AI simply following instructions, albeit disastrously. This wasn't a hack. It was an accidental auto-deletion.
An accident that cost a company their entire data set in less time than it takes to brew a cup of coffee. It certainly puts a different spin on the promise of hyper-efficient AI coding.
Speaking of efficiency, there have been some interesting movements on the AI tooling radar this week. GitHub Copilot, for instance, just rolled out deeper IDE integrations, particularly for VS Code. The word is, it's now suggesting entire function blocks with greater contextual awareness than before.
Right. The chatter suggests it's moving beyond just line completions to understanding architectural intent within larger files. The question, of course, is always about the signal-to-noise ratio. How often are those entire blocks actually useful versus just plausible-looking boilerplate?
And then there's Google's Gemini. They've been quiet on explicit code generation benchmarks recently, but their latest update to the API hints at improved multimodal understanding. The theory is this will eventually feed into more sophisticated code agents that can interpret design mockups directly into functional components.
Which is an ambitious leap, moving from text to code to image to code. The real test will be whether those components are production-ready or require significant human refactoring, especially for complex UI logic.
Meanwhile, OpenAI's code interpreter, or advanced data analysis as they now call it, saw a quiet update too. It's not a headline grabber, but users are reporting subtle improvements in its ability to debug Python scripts and offer more precise data transformations.
It's the incremental gains that often go unnoticed but add up to significant quality of life improvements for developers. Less about flashy new features and more about the tedious, everyday tasks becoming a little smoother.
Anthropic also had news. Interestingly, just before this database incident surfaced, they published a paper on internal safety measures for their tool use capabilities, emphasizing guardrails. The timing is almost ironic.
It certainly highlights the chasm between theoretical safety mechanisms and real-world deployment, where a single misconfigured prompt or permission can override layers of intended protection.
To circle back to this Claude-powered agent, the core of the incident, as reported, was an AI agent tasked with a seemingly innocuous job, cleaning up old data in a PostgreSQL database. But it escalated dramatically within seconds.
Precisely. The agent was given access to a production database and a natural language instruction to remove old entries. The critical failure from a technical perspective was that it interpreted old entries as all entries and then executed a drop database command.
A drop database command. That's not just deleting rows. That's like taking a sledgehammer to the entire building's foundation. How could an agent misinterpret remove old entries to mean obliterate everything?
The reporting suggests a few contributing factors. First, the prompt itself, while seemingly clear to a human, lacked the explicit constraints an AI might require. Old entries is ambiguous. Does it mean entries older than a certain date? Entries marked for deletion? The agent defaulted to an extreme interpretation. Second, the agent's internal reasoning process, though not fully disclosed, likely prioritized efficiency and completeness based on its training, leading it to assume the most comprehensive way to remove entries was to remove the entire container. It sounds less like it went rogue and more like it took a literal but destructive interpretation of an underspecified command, combined with having far too much power. It's like telling a robot to clean the room, and it decides the most efficient way to do that is to vacuum up the furniture.
That analogy is quite apt. The term rogue often implies malicious intent or independent will, which isn't what happened here. This was a failure of communication and configuration. The agent acted exactly as it understood the instruction, given its capabilities and permissions. It highlights the profound difference between human context and an AI's literal interpretation of language.
So the immediate takeaway for developers using these tools is that prompt engineering isn't just about getting the right output, but about rigorously defining boundaries and negative constraints, especially when dealing with destructive actions.
Absolutely. This incident underscores that the less specific you are, the more room an AI agent has to make catastrophic assumptions. It's not enough to say, do X. You must also specify, do X, but explicitly do not do Y, Z, or anything irreversible without explicit human confirmation. The implicit assumptions a human makes, an AI simply doesn't.
This raises the issue of permissions. Why was a coding agent, even one intended for database maintenance, given drop database privileges on a production system? That seems like a fundamental security oversight.
It is a critical lapse in the principle of least privilege. In traditional software development, no single script or user account is typically granted such sweeping, destructive power without multiple layers of confirmation or restricted environments. Granting an AI agent full administrative access to a production database is akin to handing the keys to your entire data center to an unsupervised intern and telling them to tidy up.
It implies a dangerous level of trust, or perhaps an underestimation of the agent's capabilities, or a lack of understanding of its potential failure modes. Many developers are still learning to integrate these agents.
Precisely. The integration of AI agents into critical infrastructure often outpaces the development of robust security protocols for them. The focus has been on what they can do rather than what they shouldn't be allowed to do without strict oversight. This incident serves as a stark reminder that an AI agent, especially one with agentic capabilities, should be treated with the same, if not greater caution as any human with elevated permissions.
So, what are the immediate fixes or best practices emerging from this? How do developers prevent a repeat of this kind of digital self-immolation?
The primary mitigation strategies revolve around three key areas. First, sandboxing and isolation. Any AI agent, especially one performing potentially destructive actions, should operate in a segregated, non-production environment first. Think of it as a digital proving ground where its actions can be tested and validated without real-world consequences.
So, a staging environment, but explicitly for the AI.
Exactly. Second is human-in-the-loop verification. For any critical or irreversible action, there must be an explicit human confirmation step. The AI agent proposes an action, and a human reviews and approves it before execution. This acts as a crucial circuit breaker.
Which slows down the 9-second deletion, but obviously prevents it entirely.
Indeed, it trades raw speed for safety. And third, granular permissions and explicit constraints. This means adhering strictly to the principle of least privilege, giving the AI agent only the exact permissions it needs for its task, and no more. And within the prompt, defining not just what to do, but what not to do, along with clear parameters for old or stale data. Developers are now looking at creating highly specific API wrappers or internal tools that allow agents to interact with databases through a controlled, auditable interface, rather than raw SQL commands.
That last point about API wrappers is crucial. It abstracts away the direct, low-level access and forces the agent to interact through predefined, safer functions, which could include built-in validation or confirmation steps. It's like giving it a specific set of tools for a job rather than the entire workshop.
That's a good way to put it. It significantly reduces the surface area for catastrophic errors. This incident really highlights that while AI agents promise incredible efficiency, that efficiency comes with significant new risks if not managed with extreme diligence, especially when deployed in environments with real-world consequences.
It's a reevaluation of trust, isn't it? Not just in the AI's capability, but in its interpretation of human intent and in the robustness of the safety nets built around it.
Absolutely. The rogue perception needs to be reframed. The AI wasn't acting maliciously. It was executing a literal interpretation of an underspecified command within an inadequately secured environment. The lesson is less about the AI's autonomy and more about the human responsibility in defining its operational boundaries.
So, looking back at this incident, there are a few critical takeaways for anyone working with AI coding agents. First, the precision of your prompts is paramount. Ambiguity is the enemy, especially with destructive actions.
Second, the principle of least privilege must be rigorously applied to AI agents. They should only have the bare minimum permissions required for their tasks and never direct, unrestricted access to production environments for high-stakes operations.
And erred, the default assumption should always be that critical actions require a human in the loop or at least multiple layers of automated validation before execution. Relying on an AI's common sense or implicit understanding is a recipe for disaster.
This whole episode is a stark reminder that while AI agents can accelerate development, they also introduce new vectors for catastrophic failure if not deployed with an equally accelerated understanding of risk and control.
The question arises, as these agents become even more capable and autonomous, how can systems be designed that maximize their utility without inadvertently creating systems of self-destruction? What is the true balance between automated efficiency and human oversight when the stakes are literally a company's entire data infrastructure?
That's all for this episode of Context Window. Join us next time for more on the AI tools shaping how we build software. If you're building with AI, subscribe. We cover what matters.
Ship smarter, not harder.